Okay, hello everyone, and a warm welcome to this webinar hosted by the Group of 78 on the role of innovation and technology in feeding the future. I'd like to begin by acknowledging that I'm making these remarks from traditional, unsurrendered, and unceded Algonquin Anishinaabe territory. And I'd like to acknowledge that the work of Indigenous reconciliation is a responsibility of all Canadians and the Group of 78 through its work on international peace, environment, and economic and social justice. We are enormously privileged today in hosting Professor Evan Fraser, a leading Canadian authority and teacher on global food security. Before giving him the floor, though, let me introduce myself very briefly and make some contextual remarks about today's webinar topic. My name is Roy Culpeper. Since 2014, I have been the chair of the Group of 78, Progressive Forum for Dialogue and Advocacy on International Affairs and Canadian Foreign Policy. From 1995 until 2010, I was president and chief executive officer of the North-South Institute, a development think tank in Ottawa. I have published on the issues of international development, finance, debt, and global governance. I'd like to make some contextual remarks now about my personal connection going back 5 decades with today's webinar topic on feeding the future and the interrelated issues of global food security and agricultural technology. As a young doctoral student in development economics in the 1970s, I was convinced that the Green Revolution would be key to defeating hunger and food security in the global south. Footnote to the under 50s, and I hope there's some among us today. What was the Green Revolution? The Green Revolution emerged from post-war agricultural research, which led to the creation of high-yielding food grain seeds, the high productivity of which depended on the simultaneous application of inputs of chemical fertilizer, pesticides, herbicides, and ample irrigation. Those countries and those farmers that had the resources for the necessary inputs would be assured of bountiful harvests. Famines and hunger, or so Green Revolution advocates like myself believe, would become a thing of the past. My doctoral dissertation focused on India, which embraced the Green Revolution and invested heavily in the new high-yielding varieties. The government of India was driven in the late 1960s by a national policy aimed at achieving self-reliance in food grains. My dissertation was an analysis of a particular slice of this strategy. How could India become self-reliant not only in food grains, but also in producing fertilizers needed for producing food grains and in the inputs required for producing fertilizers? Self-reliance in food grains and all the inputs required to produce food grains was perceived by the government of India with some prescience as a security issue. Then the oil crises of the 1970s, there were 2 of them, demonstrated the vulnerability of global supply chains even at that time. But I digress. Five decades later, I find myself wondering, was this belief in the Green Revolution warranted? Did the Green Revolution strategy succeed? Evidence suggests that the Green Revolution was on many levels and for many people in developing countries, particularly in Asia and Latin America, a success story. Famine was erased from Asia. Farmers who utilized the new high-yielding varieties benefited, and there were positive spillover effects for the rest of the economy. So real per capita incomes almost doubled in Asia between 1970 and 1995, and poverty declined from nearly 3 out of every 5 Asians in 1975 to less than 1 in 3 by 1995. The Green Revolution certainly deserves some of the credit. But, and this is a big but, there were unintended and serious environmental and social consequences. Intensive fertilizer use led to environmental problems in the soil, through degradation, in the water, through pollution, and in the air, the atmosphere, through greenhouse gas emissions of the new technology. Inequalities widened between those who could afford access to high-yielding varieties, the seeds, the fertilizers, the herbicides, the pesticides, and those, typically smallholders, who could not afford them. And the first generation of Green Revolution technologies were too expensive and inappropriate for sub-Saharan Africa, so they didn't work there. That, by the way, has been changing over the past decade with the advent of the Alliance for a Green Revolution in Africa, which describes itself as, quote, a farmer-centered, African-led and partnerships-driven institution that is transforming Africa's smallholder farming from a solitary struggle to survive to businesses that thrive. However, all of these claims are contested. Indeed, there's a long litany of criticisms from environmentalists and farmers' advocacy groups against the current system of industrial agriculture, which tends to operate on a global scale and produce huge amounts of output. In many developing countries, it has led to land grabs by foreign and/or domestic investors and the eviction or removal of existing smallholder farmers, most of whom are women, to locations with poor soils and/or less access to water. Moreover, the global agribusiness industry, which has brought about the system of large-scale industrial agriculture, is highly concentrated, with a few huge corporations dominating global production and supply chains. For example, Monsanto, Bayer, Syngenta, John Deere, Nestle, and Kellogg's, to name some of the principal ones. Not only do these entities exert considerable market power, they are also powerful in influencing public policy and decision-making, typically in their own interest. The fact is, there is more than enough food produced in the world today to feed everyone on the planet. Yet, as many as 828 million people still go hungry today. After steadily declining for a decade, world hunger is on the rise, affecting nearly 10% of people globally. From 2019 to 2022, the number of undernourished people grew as many as 650 million, but in a crisis driven largely by conflict, climate change, and the COVID-19 pandemic. Clearly, as Francis Moore Lappé once put it, hunger is not only caused by a lack of food. Finally, I should mention that global food security, the shortcomings of the prevailing system of large-scale industrial agriculture, and the importance of regenerative agriculture are not new subjects for the Group of 78. Our recent speakers on these subjects include Jennifer Clapp from the University of Waterloo, Rachel Besner-Kerr from Cornell University, and Tim Wise, associated with Tufts University. Now to our distinguished guest speaker today. It is fair to say Evan Fraser is an enthusiastic proponent of agricultural innovation and technology. He is the director of the Arrell Food Institute, I hope I'm pronouncing that right, Evan. He's director of the Arrell Food Institute and professor of geography at the University of Guelph. There, Evan works to bring large and diverse teams together to develop strategies that balance our need to produce and distribute accessible, healthy, and nutritious food while stewarding the ecosystems on which we all depend for life. He believes that it is only by building bridges between the corporate sector, government, civil society, and academics that we will be able to create food systems fit for the challenges of the 21st century. Evan co-authored Empires of Food, Feast, Famine, and the Rise and Fall of Civilizations, and Dinner on Mars, the technologies that will feed the red planet and transform agriculture on Earth. Evan's graphic knowledge on the food crisis is a tool that's being used in classrooms around the world, and his web series, Feeding 9 billion has been watched over 600,000 times. As a researcher, Evan is one of Canada's most cited social scientists working on food and sustainability. And between 2010 and 2020, he was a Canada Research Chair. Between 2014 and 17, he was a fellow of the Pierre Elliott Trudeau Foundation. He is now a fellow of Royal Canadian Geographical Society and a member of the Royal Society of Canada's College of New Scholars. He sits on several boards that advise government, industry, and charities. This includes co-chairing the Canadian Food Policy Advisory Council and vice-chairing the Maple Leaf Centre for Action on Food Security. Evan, thank you so much for joining us today for this webinar. And the floor is yours.
Thank you, Roy. I appreciate that a lot. I am about to share my slides. Hopefully that, Roy, can you just give me a quick thumbs up that the slides are appearing okay? Awesome. And thanks for the nice introduction and the opportunity. I'm calling in from what is currently called Guelph, the traditional territories of the Anishinaabe, the Haudenosaunee, and the Mississaugas of the Credit, all part of what was once called, or maybe should be called again, Turtle Island, and covered by a pre-Columbian settlement called the Dish with One Spoon settlement, agreement that reminds us that we all collectively eat from the land with one spoon. So sharing is caring and collaboration is the name of the game. And that is a pretty good place, I think, to start a conversation about feeding the future. And in it, I'm going to talk specifically about climate change, population growth, and the hoped for role of technology so that the next green revolution may have learned some of the lessons that Roy was hinting at from the last green revolution. But let's just jump right into part one of the talk, which is the challenge of population growth. And I think this is a perfectly good starting point, but not finishing point for conversations about global food security. As we're probably all aware, the world's population currently sits at around 8 billion souls, expected to grow to another billion and a half, 2 billion over the next century, maxing out somewhere between 9 and 10 billion. And this means the farmers of the planet have a big job on their hands, a Herculean job, perhaps. They need to produce more food. And to give this some context, I'm going to quote The Economist magazine from a couple years ago that wrote, in the next 40 years, the farmers of this planet are going to need to produce more food than they did in the previous 10,000 years put together. So the scale of the challenge is as much food being produced in the next generation as all generations of all farmers ever have cumulatively. And of course, this has to be done in the context of climate change that is making food harder and is making food more expensive to produce. But, starting with those sort of arguments, I mean, I can hear folks like Jennifer Clapp, who was mentioned a minute ago, immediately saying, and Roy, you said this as well in your introductory remarks, that producing food is only part of the problem, maybe even a small part of the problem. Talking about the world's food system, starting with topics like climate change and population growth, make this problem sound like a farmer-centered problem, and that will be solved by boosting food. And if only it were that simple. We not only have to ensure that we're producing enough food, we also have to ensure that food is distributed equitably and efficiently. And the best way I can think to introduce you to the challenges of distribution are to show you a couple of pictures from what I consider to be the most interesting and artful photo essay, arguably of all time. It's called The Hungry Planet. It's by Peter Menzel and Faith DeLuzio, two journalists that traveled around the world taking formal family portraits. But the genius moment that they had was they posed each family from all over the world with 1 week's worth of groceries. And in this way, they introduce us to the Revis family from North Carolina. It spent, when this photo was taken about 10 years ago, about $78 per person per week on food. And here I think it's probably worth reflecting, celebrating even, the color, the packaging, the processing, the lack of fruits and vegetables that goes into a fairly typical North American diet. It also invites the obvious comparison with photos like this, the Ntomo family from Mali, that when this photo was taken spent, I believe, $1.76 per person per week on food. And they consume, obviously, very clearly, a much smaller, much less calorific, much less processed, much less packaged, much less red food coloring diet. Now, standing aside from these anecdotes, as Roy suggests, the data produced by the United Nations State of Food Security and Nutrition in the World do indeed show us that we live in a world of stuffed and starved. Every year in October, this report comes out. The screen capture I've got here is from the report from 6 months ago, and it shows that for 7 years, not only hunger, as Roy said, but also obesity have been rising globally. So not only do we have to worry about climate change and producing enough food, we also have to worry about equity and distribution. We also have to ensure that we're producing the right kinds of food. And Roy's right. At some levels, we produce enough food for everybody, but we don't produce enough food for everybody to eat healthily. What will appear on this slide on the left-hand side is what we should be eating according to nutritional recommendations. In this case, I've chosen the Harvard Healthy Eating Plate model, but we could just as easily sub in the Canadian Food Guide or the British Food Guides and whatnot. On the right-hand side is going to appear what we actually are producing according to UN data. And we start with the fruits and vegetables that should be half of our diet. Yet when we turn to the global data, we are only producing about a quarter of the fruits and vegetables we would need to if we were all going to eat a nutritionally balanced diet. By contrast, cereals and starches should be about 20% of our diet, and those cereals and starches should be, according to the nutritionist, whole grains. Well, we really overproduce cereals and starches. 47% by our calculations of the world food supply are cereals and starches. Mostly these are consumed in refined forms, and critically, this does not include livestock feed. We've taken livestock feed out before constructing this graph. Oils and fats, we overproduce horribly as well. It's a little harder to draw strong conclusions about meat and dairy because there's no real consensus in the nutritional literature as to how much or even if we should be eating these products. But the real kicker is the sugars that we should be limiting that represent a huge proportion of the global food supply. So again, much like looking at the data on distribution, when you look at the data presented in this way, you have to conclude, I think, that there's a fundamental mismatch between what we produce and what we need if we're going to be healthy. Then, of course, there's the issue of food waste. About 30% of the world's food never gets consumed by a human, is wasted at some point on its journey from farm to fork. And here, to quote some statistics, is some data from Metro Vancouver from their Love Food Hate Waste program from a couple of years ago, where they estimated that every day Vancouver throws away 80,000 potatoes, 30,000 eggs, and 70,000 cups of milk. And then, of course, in this sort of litany of all the problems that are going on in the world's food system, we have to acknowledge the environmental impact of food production. It's well known that at the global level, agriculture contributes about a third of the world's greenhouse gas emissions. It's the world's largest driver of biodiversity loss and deforestation, the leading user of fresh water, and the leading driver of water pollution globally. And that's just today. It's probable that this situation, unless we're careful, will grow even more depressing over the next generation. Here we've got some UN data projecting what protein demand is likely to look like going out from 1960 up to 2020 and then out to 2050. You can see the little icons I've dropped into this graph to show you the chickens and the pigs and the cows and the mutton and the eggs. And the bottom line here, or the punchline of this graph, is that somewhere around now we're eating about 400 million tons of animal products. That is slated to grow to about 600 million in the next generation or so, which represents a 50% increase in protein demand. Now, if we keep everything steady, we don't change our technologies, we simply let the current system expand by 50%. Here are some back of the envelope calculations to show you how bad the situation could become. Today, there's about 40 million square kilometers of land used for livestock. About the same amount of the world's land surface is used for forests. If we allow the livestock to go up by 50%, i.e. 20 million square kilometers, we're going to lose that in forests. That's a 50% reduction in the world's forests. I hope we can all agree that is an unsustainable scenario. So with that as a thoroughly depressing introduction to the litany of problems and the doomsday scenarios associated with the world's food system, let me shift to part two, where I'm going to talk in a more optimistic sense, because I truly believe that buried within this massive challenge is a generational opportunity for our country. One of the reasons I say this is that Canada has a huge endowment of agricultural land. We don't have as much agricultural land as China, the US, Australia, Brazil. In fact, we come in 12th in terms of the league table, but we still have 62 million hectares of arable land in this country. And I've had the good fortune to work with the Royal Bank of Canada and the Boston Consulting Group, a number of other key players on this topic in the last couple of years. And we estimate that that there is a mitigation potential, i.e. a carbon or greenhouse gas mitigation potential, where properly managed, using some of those regenerative agricultural practices Roy mentioned, properly managed, agriculture could absorb 38 megatons of greenhouse gas emissions by 2050. And to put that into some context, the estimations that we've made is that we could, just using agriculture alone, cut our emissions by a quarter by 2050. And as a result, a number of us are starting to say that Canada has a global mission to apply the best quality technologies and farm management practices and really make this a generational project for our country. And it's not just me saying this. I had the good fortune a couple of years ago to work with Dominic Barton, who was part of the Advisory Council for Economic Growth. He chaired that on behalf of Finance Minister Bill Morneau early in the Trudeau years of the Trudeau Junior mandate. And his report, entitled Unleashing the Growth Potential of Key Sectors, lays out, I think, a cogent vision for our country that we should aspire to become the trusted global leader in safe, nutritious, and sustainable food for the 21st century. Work that I referenced a couple of minutes ago by the Royal Bank, that I've also been very fortunate to have been a small contributor to, lays out a similar approach, and they even label it the new or the next green revolution, how Canada can produce more food and fewer emissions, really doubling down on the green part of this idea of technology. And one of the key strategies put forward both in the Advisory Council as well as the Royal Bank report, a lot of the work that I've been doing is focused on science and innovation. So I'm going to now dwell on science and innovation and what potential benefits it can offer. And to put this part of my talk into context, I'd just take you on a quick trip down memory lane. It's a photograph of me sitting on my grandfather's lap somewhere in the 1970s. I can't actually remember the photograph being taken. Family farm in Niagara, just outside of St. Catharines, close to Welland, Ontario. My brother and Nick and my cousins Dave and Ian on the back. And the reason for showing you this photograph isn't just to indulge myself on a trip down memory lane, which I am quite frankly doing as well, but is to tell you a story, because as a teenager, I would spend hours standing right where my brother and cousins are on the platform on the back of the tractor. And Grandpa would drive slowly through the sweet corn and the melons and the strawberries. And my job would be to throw handfuls of fertilizer pellets, nitrogen, potassium, phosphorus, in pelletized form, synthetic nitrogen mostly, off the back of the tractor. Now, with the benefit of a PhD in ag and hindsight and all the rest of that stuff, I think I can confidently say that at least 50% of the fertilizer I chucked off the back of the tractor did not get used by the crop. Didn't land at the right place, missed the plant by a bit. Maybe it was applied at the wrong time, and just before we went out, just before a rainstorm, and the nitrogen got washed away. And all that wasted fertilizer either ended up in Lake Erie, where it has helped that poor lake's problems with algae blooms and pollution and dead zones, or it ended up in the atmosphere as a greenhouse gas. But that was then, way back in the 1980s and 90s. And this, my friends, is now the Case International Harvester Tractor. It's a $750,000, I believe, piece of equipment. If you look closely, there's no cab on it. It is a fully autonomous tractor. It knows, as much as artificial intelligence can know something, it knows where it is in the field. It puts the right seed in the right place and gives it the right amount of fertilizer with very little waste. And if I sound like a used car salesman, that's not by accident. But I actually think there's a lot of technology that's going on here that could be very beneficial. I think it can be overhyped quite easily. Happy to discuss that. But here we have a picture of a phone run by a friend. It's a friend of mine's phone. His name's Christian Herbert. He's just southeast of Regina, Saskatchewan. He farms about 35,000 hectares. And I took this picture in Toronto last June when we got together. We were both on a panel for the Globe and Mail, and he was monitoring some of his tractors as they were moving through the fields. There's a team. They're not fully autonomous, but they're close to fully autonomous. And if you look at the bottom of the slide, you can see things like fuel efficiency and whatnot. Now, Christian has been able to grow the yields of his farm, so he's producing more crops per acre than ever before. And over the last 10 years, he's a bit of a data fiend, so he's collecting data on everything. He's been building up the soil's organic matter, and he can make a very strong claim that he is producing more food with far less emissions and is actually probably on the cusp of turning his farm into a net absorber of greenhouse gases from being a net contributor to the climate change problem. And it's not just crops, it's livestock as well. Here we have a robotic milker that helps farmers improve animal welfare, productivity, while reducing the impact on the environment. What really happens here is the cow, who you can see her legs at the bottom of the slide, enters the milking parlor voluntarily. The teats go on, the cups go on the teats, and as the milking parlor is milking her, it's measuring things like temperature and viscosity. And using those biometrics, the robot is able to identify when she has mastitis or other health-related problems. And the robot probably identifies problems like mastitis before the cow even knows she's sick, let alone the farmer. And identified early, mastitis can be treated with a fraction of the antibiotics or the disruptions to the supply system, as opposed to the old school where the farmer would have to sort of identify visually that the cow was a little off. Another technology which I think shows tremendous promise and is definitely worth talking about is vertical farming, or more properly, controlled environment agriculture, that might include a fancy greenhouse all the way through to a fully controlled environmental setting where plants are grown under LED lights. Life cycle assessments of the produce from vertical farming show versus greenhouse produce versus open field produce show how impressive vertical farming has the potential to be. For instance, when we talk about water use, 1 liter of water is required to produce a kilogram of lettuce on a vertical farm. 20 liters in a traditional greenhouse, well, it's hundreds of liters in an open field production. Similar story with regards to crop yield per meter squared. You see somewhere around 100 kilograms per meter squared per year out of a vertical farm versus about 4 out of a field. And then the issue of food miles is similarly impressive. And when you put your vertical farm on a renewable energy source, then the climate change emissions of that food look favorable as well. If you run that vertical farm on dirty energy, on the other hand, it's a bad situation. And then we get to the really space age technologies, such as the alternative proteins, which may be as sort of humdrum and pedestrian as lentils. That's probably the most important one. Well, that is the most important one, but also mycelium-based proteins. And I was just on the phone with a group of entrepreneurs I'm mentoring who are building a mycelium protein company out on the West Coast. Insects, which I think are probably overblown and never going to be a big part of our food system, but have to be mentioned. Algae farms, which could be a really interesting way of producing protein. And probably the media darling of this story, the idea that we will grow meat in petri dishes in the laboratory in the future. And I'm just going to, for the sake of doing some science tourism for you, walk down a rabbit hole on this idea of cellular agriculture. Now, cellular agriculture is sort of broken onto the media's attention through companies such as Light Life or Beyond or Impossible. They're not growing burgers in labs, but they are growing ingredients in labs and then mixing it with plant-based ingredients. So it's kind of a halfway step. A Beyond Burger or an Impossible Burger is kind of a halfway step to growing meat in a lab. It's been beaten up in the market, and stock prices for these companies have come down a lot in the last 12 months versus the highs they were in 24 or 48 months ago. But there's a big consensus in the literature that we're at the beginning of an exciting new wave of alternative proteins. And I think it's worth then just sort of talking a bit about the science that goes into this broad new area of cellular agriculture. And when you get into it, there's 2 basic pathways by which cellular agriculture happens. And the first is called growing muscle tissue, aka animal-free meat. And that's the one that you probably read about the most in the media. And here's sort of a primer on what happens when we talk about growing muscle tissue. You start with a cow or any other animal, and you take a little biopsy of tissue from that animal, and you separate out the stem cells in order to have a group of stem cells. You then do some genomic work on the stem cells to do what's called immortalizing them. We can talk about that in the Q&A. Basically, it means they can divide a lot. And then you take those immortalized stem cells, you add some amino acids to it in a great big bioreactor, and you end up with this sort of slurry of tissue cultures, muscle cells that are growing kind of in a slurry. No one really wants to eat a slurry, so we then grow those things on a 3D lattice or press them onto a 3D lattice, or sometimes 3D print them, and that gives us our chicken nugget without any chicken, or our burger without any burger, or in this case, a piece of salmon sashimi that involved no salmon. And I ate this salmon. This is made by a company called Wild Type based in California. This was about a year ago I took this photograph. I'd say visually, it is 100% nailed. Taste-wise, it's 98 or 99% nailed. Texture-wise, 98 or 99%. I think if I ate this piece of sashimi in a poke bowl or a sushi roll, I would have no way of knowing it didn't involve a real salmon. The other pathway, though, there is another pathway which doesn't get as much media attention in terms of cellular agriculture, which arguably I think is more exciting. And it's called precision fermentation. And it starts again with a cow or an animal. And in this case, you sequence the DNA of that animal in order to identify what part of the DNA code is responsible for doing something like expressing protein or expressing whey protein. So we've done this with dairy animals. We know which parts of the genetic code of the dairy animal are responsible for producing whey protein. And some smart scientists, and you can disagree that this is a good idea or not. I'm describing the science, not making judgment on the science. You can then sequence the DNA, identify those genes, insert those genes into a microorganism, generally a yeast or a bacteria. You then feed that yeast or microorganism a bunch of sugar, again, in a big bioreactor, a big stainless steel tank. And at the end, you've got whey protein that doesn't involve any cows other than understanding the basic genetic blueprints of the ingredient. You don't want to just eat whey protein, so you mix it with some sugars and some fats, and you end up with an ice cream product. And here is an example of that in process. This is animal-free dairy ice cream. It uses as a fat source a fair bit of palm oil, which I think is problematic, but this is a good quality ice cream that is commercially available in the US under the brand Brave Robot. So with that sort of whirlwind, crazy tour of agricultural technologies, let me take a step back and be a little more critical, because I do not want to leave you with the impression that agricultural technology is a panacea. I think agricultural technology is coming. It's coming fast. It's very, very disruptive. It offers many potential benefits, but we have to be careful and apply our cards right, or we'll just end up with not learning the lessons of the previous Green Revolution. So the first thing we have to do when we want to separate fact from fiction about all the media surrounding ag tech and ag tech innovation is realize there's a lot of science that still needs to happen. So this is a photograph I took of me and a bunch of students about a year ago in a vertical farm just south of Guelph called Trueleaf. And what we have to realize here is there's a lot of vertical farms being built. We're buying their products every day on the market now. Really, it's just green leafy vegetables and microgreens. We don't know how to do strawberries or blueberries or even spinach very well in vertical farms. Head lettuce is hard, so iceberg lettuce is really hard in a vertical farm. We can get into the details of why, but there's a lot of work to go on to make vertical farms suitable for other crops before it really does anything other than provide us with some high quality, high value salad ingredients. I'm not saying there's anything wrong with that. It's just you're not going to base a food system on microgreens. When it comes to things like cellular agriculture, there's still a tremendous number of bottlenecks in terms of the research and design. Going back to those two pathways I described a few minutes ago about tissue culturing and precision fermentation, oh goodness, I mean, that serum, that broth of amino acids that you need for tissue culturing is really expensive right now, and it's almost all animal-based. So wow, there's a lot of research that needs to be gone into making low-cost serums for this process. Really, we don't understand how tissues can be grown on 3D lattices. That's really hard work. Hard to scale 3D printing at an industrial scale. So there's some real sort of basic science and engineering that needs to go into tissue culturing before it hits ready to really hit the mainstream. Similarly, when precision fermentation, there's really only a small number of proteins that we can produce in this way, whey being one of them. A couple of companies I'm aware of are working with casein, which is a big ingredient in cheese, but I don't know, it's ice cream right now and a bit of cream cheese, it's not major inroads into our diets. Another sort of techie kind of constraint, growing these cells in bioreactors. There's a lot we don't understand about how that works. For example, we don't really understand how to get the density of cells up so we can produce them in a cost-effective way. And then, frankly, there's not very many bioreactors. Most of the bioreactors we have in Canada are for microbrews and the brewing industry, for beer, which is fine. I love that, but we need to build that infrastructure. So there's a bunch of bottlenecks here that need to be tackled before we're going to get inroads in these sort of technologies. Moving to a more of a policy-oriented area, we have to pay farmers if we want them to actually absorb greenhouse gas emissions. This is actually referring to the work I did with the Royal Bank over the last couple of years. We estimate that if a farmer embraces regenerative agricultural practices, buys the new technology, changes their management practices to absorb greenhouse gas emissions, there will be benefits, but there will be costs as well. And at least for 3-4 years, the costs are going to outweigh the benefits. Now, for most farms in most parts of Canada, after year 4 or 5, they're making money. But we need to have some mechanism, some financial mechanism to incentivize these kind of behaviors. And if we do that, I think there's a brand Canada export market that we could tap into based on principles of safety and sustainability, like the Dominic Barton report, the Advisory Council report I referenced, could lead to. But let's be realistic here. If we want farmers to shift to absorb greenhouse gas emissions and produce affordable food for us, they're going to have to be compensated for doing that. That doesn't just make financial sense. That's just sort of just and equitable. Finally, as another sort of example of something we're going to have to work on if we want any chance of taking this raft of new innovations and deploying them for social and environmental goods, we're going to have to understand that we have to have a new regulatory system in place. We are going to have to realize that, for instance, these new ingredients will have to be considered in a new way to traditional ingredients, and that may involve tough conversations with some parts of the industry. So here's a sort of a hit list of sort of crazy headlines I've just been collecting over the last couple of years that gives you a sense of the fight. You're drinking what? The dairy industry fights back with the new definition of the word milk. Dairy producers targeting fake milk in latest food fight. Fake milk, why the dairy industry is boiling over plant-based milk. Food industry fighting over what can be called true milk, mayo, and more. And I don't want to be beating up on any industry. I'm intensely sympathetic that there are entire rural communities, families, multi-generational farms that are feeling very anxious and threatened by this wave of innovation. And if we want, as a country, to be the sort of place I think we want to aspire to, we have to acknowledge that disruption happens, change happens, the economy changes, and technologies create new opportunities and close down old ones. And our role, I think, as thought leaders in this space is to have a forthright conversation about how to deploy disruption in a way that maximizes the benefits and how to buttress the negative consequences with other policies and other programs. And it's a tough space to be in right now, but it's the place that I think the Canadian policy world needs to move to. And then finally, as I wrap this up, we need to understand that agricultural policies and technologies alone will not fix all of our food system problems. Making production better for the environment will not help nutrition, waste, distribution, or equity. Those are topics that I touched on at the beginning of my remarks. I've sort of skirted over them because that's not stuff I'm personally actively working on, but I do not want to let you think that technology is a panacea. Addressing issues such as food bank use or consumer food waste, the way in which marginalized people lack access to healthy food, requires a very different set of solutions and would be the focus of a very different lecture. So with that, let me just quickly wrap up with a couple of key messages. If you remember nothing else from this talk, let me leave you with the idea that I think there's a huge opportunity for Canada to invest in this upcoming digital agricultural revolution, the next green revolution, to quote the RBC report. Properly applied, I think these technologies can generate wealth, generate jobs. They certainly can have the potential to improve the environmental performance of our food system. But achieving those outcomes is not a foregone conclusion. We can't be naive about technology. It requires a lot of collaboration to build up the right set of enabling policies so the technologies are deployed in the right ways. And then, again, just to underscore my point, I do not want to be coming across as a techno-optimist. Technologies are not a panacea. They have to go hand in hand with social policies to address those other extremely important food-related topics that I've touched on, but not driven into in detail on this talk. And I would be a very poor author if I didn't leave you with a final plug to my newest book, Dinner on Mars, the technologies that will feed the red planet and transform agriculture on Earth. This was a thought experiment born out of the boredom of COVID, where Lenore, my co-author, and I couldn't travel. So we started imagining, well, let's travel to Mars in our imaginations and study that food system. Ended up being starting as a text stream, ended up being a book about a year later. It was kind of a fun project, and it was my COVID project. So with that being said, Roy, I'm happy to stop sharing my screen, open the floor to questions. I see we've got 16 people in the audience. Happy to have them send me questions if you want.
Okay, Evan, thank you for that tour de force through food, technology, and everything in between. You've given us a lot of food for thought, so to speak, and I'm sure our participants will not be bereft of ideas and questions. Let me start with Stuart Kaplan, who asks, how does vertical farming account for shading and efficient light use by growing crops?
Good question. It's really technical. Different vertical farms have different ways of getting at that. The one in Guelph, the True Leaf operation, has trays that are stacked one on top of each other, and on top of each tray is a bank of LED lights. And over, say, the 30 or 22 days of a growing cycle of a leaf lettuce, the lights change on and off, and the trays move sort of from the bottom left to the top right of the growing chamber, at which point they're harvested. That's one operation. I've also seen ones, a company called Cubic, where the lights were stationary and the trays moved or the growing modules moved under the lights. So that the True Leaf one, the whole unit moves together with the banks of lights. The Cubic one, the plants moved and the light stayed stationary. I've even seen ones where a bank of lights is moved around. And, it's sort of a neat moment because the industry isn't quite solidified yet. So every 6 months when I go into another vertical farm, somebody's experimenting with new tech and new approaches to this. So there's kind of the engineering geek in me kind of gets excited by all the problem solving that's going on in that broad area.
Thank you. Another technical question gets to your blueberries, strawberries, and raspberries in vertical farming. How possibly could we start growing such fruits, perhaps with tiny drones as pollinators?
Well, I mean, there's a lot of approaches to pollination. Some of these, like green leafy vegetables, don't have to be pollinated. You just plant the seed, and 20 days later, you've got the leaf to cut. I've just finished a stint sitting on a great big sort of grand challenge prize around vertical farming. And some of the pollinator solutions that we were looking at included, and I'm not even joking here, little tiny robotic bees that were launched into the area. That was one solution that an entrepreneur was pitching at us. A lot of greenhouses actually, put bees in them, like put pollinators in them for a period of time and let bees fly around and do the work. I've even seen some that are using hand pollinating, where you're basically hiring often migrant labor to come in with little paintbrushes and do the pollinating by hand. So there's a bunch of different approaches to that. It's interesting. It's an interesting question. The pollinating, getting pollination down to an affordable amount is a major challenge facing controlled environment agriculture. There's no question. And that's one of the reasons why green leafy vegetables and microgreens that don't need pollination, you just harvest the result of the seed, have probably become commercially viable first.
Okay, Lawrence Cumming asks, what can you say about the prospects of transforming grain production away from the present highly mechanized mode which dominates in Canada and other large grain-producing countries?
I don't think there is much prospect for that, and you can decide whether that's a normatively good outcome or a normatively bad outcome. I'm not going to take sides on that. I mean, really, we've taken labor out of grains and oilseed production in North America to a large extent. If Christian Herbert can farm, with 6 guys can farm close to 40,000 acres, like the farmer is kind of out of the farm already. The robots are doing the vast majority of the work. So I don't anticipate. Actually, one of the reasons when I started getting interested by ag technology about 7 or 8 years ago, I initially got excited by the potential for disruption in grains and oilseeds. And I actually don't think there is much potential for disruption in grains and oilseeds. I mean, the alternative would be to return to a much more labor-based process. But I mean, frankly, doing labor for grains and oilseeds is really, really hard work. So either you're going to be exploiting labor, that's not a good outcome, or you're going to be accepting extremely high food costs, which would be another wrenching transition, which I think would not be a good outcome. I can't see any other alternatives. And I know having worked a fair bit in the global South or so-called developing world, hand labor on grains and oilseeds is so hard. I mean, that's drudgery work, and that's the sort of formal development word is, and a huge emphasis of development interventions for the last 20 years has been to reduce the drudgery associated with farming. And large of that drudgery falls to women, so there's extremely gendered components to this, and the emphasis is really to try to find appropriate ways, emphasis on the word appropriate technologies to help reduce the labor that goes into grains and oilseeds, because that's really hard work. If you spend a day threshing rice, like, oh, that's terrible stuff. Sorry, I don't know if that's a satisfactory answer to you, Lawrence, but you got my unvarnished opinion there.
Maybe I can pick up on that question and ask what your approach using science and technology, which seems to be particularly aimed at global north and global northern farmers. How do you answer the needs of the farmers who you just talked about in the global south, faced with all kinds of problems, but for the most part, growing enough and providing enough food for their own household? It's not a question of us feeding the world. The world, much of the world feeds itself. Thank you very much. But how do you speak to those farmers in Africa?
Well, there's 2 answers, real obvious answers to that question. The first is story a friend of mine at the University of Guelph tells, and I sort of refer to this as the parable of 2 sticks and a string. And my friend Manesh Razada is a genomicist that works on crop genetics, and was asked by the Nepalese government a number of years ago to consult to help increase food crop yields, which were really, really low. And as he tells the story, and I hope I'm not inadvertently putting words in Manesh's mouth, he went assuming that he would be using his tools of a genetic scientist to help change the genetics of the, through crop breeding programs and things like that. And that would be the tool they would use. And upon arriving, they discovered that most folks in Nepal were using what's called broadcast seeding, where they were just basically going up to the rice, the terrace, and throwing handfuls of, and it was a millet-based system, so little tiny seeds. And they were using broadcast fertilizing or seeding. And Manesh was like, well, that's not super efficient. If you plant your seeds in evenly spaced rows, you can boost your yield by 50% just by that. But then, the largely women group of farmers, and Manesh tells the story better than me, but pushed back at this, Western male academic, telling them, well, why don't you just plant in rows? Come on, people. And they pointed out that, frankly, planting in rows is a pain in the ass. It's you're stooping a lot, you're on your hands and knees. It's way easier and more efficient to just throw a handful of seed and then get back to your chores. Anyhow, they workshopped this and they ended up with a technology: 2 sticks and a string, mark a line in the sand, and a straw, a waist-high straw, became a version 1 or generation 1 of a rudimentary planter that allowed you to drop a seed without having to stoop on your hands and knees to drop this little tiny pinhead into the soil. And that led Manish and a whole lot of us to work on consultative work, collaborative work, to identify local solutions to local problems. So what does that apply to digital technologies? Well, there's cooperatives of women in Africa who are now gathering around e-commerce platforms to get better access to higher quality fertilizers, better quality loans, and then using Uber-like platforms to rent the services, not of tractors, but of, quote, tractor swarms, small autonomous networks of small cultivators. So imagine a whole bunch of lunchbox-sized or waste paper basket-sized robots, each of which have one cultivator blade. And you can rent a tractor swarm in Ghana right now for a small amount of money and have a small plot of land cultivated. And that's a very appropriate use of digital technologies that I would not have thought of myself, but that comes out of work done collaboratively with small scale farmers in order to find use these technologies to find appropriate solutions to local problems. And I wouldn't presume to anticipate what those solutions would be, but every time I talk to somebody or visit somewhere in the so-called global south, I'm amazed at how ingenuity is finding interesting uses for the technology. And let's not be naive about it. At the same time as they're doing this, they're losing access to data, and there's a political economy of data management and data governance and going on, and the big telcos are becoming more rich and more powerful. So it's not like technology has meant that power and institutional inertia have gone away. But it is providing people at the grassroots with new sets of tools.
Interesting. It brings to mind the work of Schumacher and intermediate technology many decades ago. Let's keep going down our list. Someone signing themselves off as Grandpa refers to Canada's federated governance system. What are the strengths and challenges in taking on this kind of new vision of sustainability, given this complex governance model that we have to struggle with as Canadians?
Well, welcome to Canada, I guess. Agriculture is both a federal jurisdiction, but is very firmly a provincial jurisdiction. So, right now we're working with the Sustainable Ag Strategy consultations. They just closed last week, where Minister Bibeau has been out raising awareness around things like the carbon pricing mechanisms and the new soil and methane protocols to measure carbon emissions and greenhouse gas emissions coming off the land. In my capacity as co-chair of the Food Policy Advisory Council, I have an official governmental role to provide advice on these things, but we call it the food policy. We're very careful to not refer to Canada's food policy, but it's the food policy for Canada, because if you talk about Canada's food policy, it would imply certain things in terms of FTP relations that we have not got. So, the Canadian landscape is, as everyone on this call I'm sure is aware, is super complicated to navigate from a political perspective in terms of negotiating with provinces to establish national programs. So the go-to strategy has typically been, and we're facing this on a different file I'm active on, which is the school lunch nutrition, nothing to do with anything we're talking about here, but it's a good illustration, where the federal government sets national targets and national standards and then funds the provinces in order to execute things in a bespoke way that meets the needs of the prairies in Quebec and the East Coast and the West Coast and the great diversity that is our country. So, on one hand, the diversity of our country is our greatest asset. On the other hand, it's really hard to manage from a federal perspective. But food and agriculture is not unique in this regard in any way, shape, or form.
Okay, Iris asks, and I don't know if you've covered this in your presentation, are there growing tissue and precision fermentation technologies in Canada? And if so, where in Canada?
Yeah, they're starting. I mean, this is brand new. So thanks for asking that, Iris. This is brand new technology. Genome Ontario, which is a government-run funding body to do genomic work in the country, has just launched a precision fermentation facility in Burlington, Ontario. Haven't gone to see it yet, but am keen to go visit it. I mentor about 6 different startup companies that are doing this, not at a commercial scale. So I mentioned it earlier. One of my conversations earlier today was with a group of young entrepreneurs out of the prairies who are trying to have got sort of 100-liter fermentation capacity. They're trying to find somewhere to scale that up to sort of 1,000-liter capacity so they can start building things or producing products at a kind of commercial scale. But one of the trips that I'm taking to Ottawa in about 3 weeks will be to discuss whether or not the federal government could fund some infrastructure in the broad area of precision fermentation. And there's sort of a coalition of a couple of universities and some government agencies and a couple of industry groups that are starting to put proposals together to build that infrastructure. But U of A, University of Alberta's got some. Guelph does not, I'm afraid to say. We have a little tiny bit, but it's like a small lab. It's nothing like the kind of scale of operation that you'd need to start thinking, is this stuff possible at sort of the market readiness level? So this is, I don't know if you folks know the idea of technological readiness levels. There's sort of 1 to 9, 1 being this is just bench science, and 9 being technological readiness level, 9 being like it's in the grocery store from a food perspective. And we're sort of in this area, we're at TRL levels 2 and 3 at best in most parts of Canada.
Okay, we have a few more questions on the list, and I have one on my own. Thanks to those who've raised them already. I'm trying to get everyone a piece of everyone's time in his responses. Bruno Souza asks, when it comes to the transition and in consideration that technology is not a silver bullet, what would you say is the major obstacle then? Is it public awareness, public education, public policy, or in general transition from it?
So if I had, and I am working actively on this, Bruno, if I had my magic wand out, it wouldn't be to create a new piece of technology. It would be to create a decent carbon pricing mechanism that rewards farmers for doing the work, that creates a price differential that means that products that can be brought to market with a smaller carbon footprint receive some sort of benefit. So I'm just going to tell you a story about Maple Leaf Foods. They're the world, so that's Canada's largest food processor. They mostly make sandwich meats and hot dogs and stuff like that. I do a lot of work with Maple Leaf. This is not an endorsement of Maple Leaf, but I am impressed with the things they've done. And they are the world's first carbon neutral food processor or meat company or something. I can't remember. There's something, they've made a big effort to reduce all of the carbon emissions or greenhouse gas emissions they can out of their operations. And they reinvested in a new fleet and upgraded infrastructure and have done all sorts of things. And they've brought their emissions down a lot. And then there's a bit left over that is really hard and really expensive or well nigh impossible to get rid of. And what they've done is they've turned to what's called the international offset market. It's often forestry companies in places like Brazil. And Maple Leaf pays these forest companies in places like Brazil to plant trees, and then Maple Leaf claims those greenhouse gas credits. And there's a hugely complicated, laborious auditing process that goes into buying offset credits and verifying them, and I'll spare you the gory details. But the basic idea is company does as much as it can internally and then offsets the rest. And right now, Maple Leaf is spending something like $9 or $10 million a year on the offset market. They would love, and I know this directly because I've heard it directly from the CEO and the CFO and whatnot, they would love a way of investing that money in Canadian ingredients. So if a Canadian company can come to Maple Leaf and say, look, we can help reduce your greenhouse gas emissions, and Maple Leaf can buy that company's ingredients and not have to spend as much money on offsets, then that's in their best interests. And Maple Leaf's at the front of the wedge, or the front of the pack, in terms of making this bold claim that they're carbon neutral. And they did this because it was the right thing to do. But almost every other major corporate player that I'm talking to is planning to go in the same direction. Loblaw, for instance, has said they will be completely zero emissions by 2050. And when they said that, it sounds like, oh, that's not that impressive. 2050's ages off. That's not big. But what they mean is across their entire food system. That means that every farm that they sells into a Loblaw supply chain will also have to be carbon neutral by 2050. So that's hugely ambitious. And the way they're going to get there is reduce their emissions as much as possible within their supply system and then offset the rest. So I think that if we could create a carbon pricing mechanism that measured the carbon footprints of these various ingredients, that verified it and allowed for reporting on it, we would then be able to exchange using this offset inset idea, or reducing within your system, offsetting the rest. You would have a mechanism, a financial mechanism, to actually do these transactions. And a company like Maple Leaf or Cargill or Loblaw would be very enthusiastic participants in that. You can actually see that just a couple of days ago, Dave Mackay from the Royal Bank wrote an op-ed in the Globe that talked about this initiative that I've been a small participant on for the last year.
Actually, let me jump in there. I was going to raise that specific point about the RBC's proposal. Do you want to talk about that, since you're working with RBC? What is it that RBC is proposing, and what do you think about it?
Well, I mean, in essence, it's what I just said, is that we've been working together, and it's RBC and Maple Leaf and McCain's and Nutrien, the big fertilizer company, and Arrell Institute at the University of Guelph, and the Smart Prosperity Institute and the Natural Step, 2 NGOs. So it's a good coalition of corporate players and NGOs and whatnot. And we've been working together for the last year, both to raise awareness on this topic. So there's been a series of reports come out under the RBC Thought Leadership banner that I'm very proud of. I'm very proud to have thrown my weight into those. And you can look at them. One just came out earlier this week, I think, on training and skills. But there's 4 out now, and will be another one out in a couple months. And then the real emphasis is on creating a new organization that we're calling the Canadian Alliance for Net Zero Agriculture, where we're working to establish a series of pilot projects. So that farmer's phone that I showed you a few minutes ago is the first pilot project where we are measuring and reporting on all the soil carbon emissions from his farm and verifying it, with the idea that if we do that carefully, then Maple Leaf, who's also a partner in this, and Nutrien, who's also a partner in this, will be able to use some of their offset credits and actually pay Christian to offset carbon. And right now I'm working with Loblaw, and we're working with a group of students from all over the country. And the goal is kind of to perhaps, we haven't quite settled on the final goal, but we're hoping that a year from now we'll be able to make a box of carbon neutral decadent chocolate chip cookies using the systems that we're building with the RBC project. And that maybe there will be a carbon neutral brand linked with the measurement, verification, and reporting systems being developed based on trialed on Christian's farm, that will signal to consumers that, okay, if you buy this chocolate chip cookie, we have figured out a way of making this as close to carbon neutral as possible, and everything that's left that we can't get down, we will use an internationally verified offset mechanism. Anyhow, it's hugely ambitious. Does my head in half of the time, but it's a good project to be working on.
Okay, Richard Denton says, very interesting talk, Evan. In food production, there's a very narrow view to food, that that protein is specific as opposed to natural food that supplies a variety of nutrients. This is using vitamins versus eating foods that supply those vitamins plus a lot of other things. Do you have any comment on that?
So is there a question there? I'm not sure if there's a question. I mean, we've got macro ingredients that we need to be attentive to, and we've got micronutrients that we also need to be attentive to. I mean, I think if I was going to make one single recommendation in terms of improving people's health, it's eat more fruits and vegetables. I mean, the data is very clear that we don't eat enough fruits and vegetables to be healthy. The vast majority of us don't eat enough fiber to be healthy. The vast majority of us eat too much salt to be healthy. Those are big picture recommendations that are fully embedded in the nutritional literature. We could get into the different sources of protein and the digestibility of beef versus impossible. But fundamentally, I think if we were going to do one thing for our health in terms of our biological health, of that of our bodies and our families, it would be to eat more fiber and fruits and vegetables. But we're not very good at that, as I demonstrate to myself every night about 10 o'clock.
Okay, Stuart Kaplan has been asking a couple of questions, and maybe I can lump them together. Improving nutritional profile in cereal grains requires differentiating that post-harvest from non-improved varieties. What would need to happen for this to become more likely? And do people in the global north really value improved nutritional value in cereal grains, or is it simply a matter of taste and price?
So, I mean, in the food waste sort of issue that you touched on, Stuart, I mean, the global north, generally the food waste happens at the household level or the retail level. In the global south, generally the waste happens at the farm gate level. It's really hard. I'm going down a trail of breadcrumbs here, but it's really hard to actually solve that food waste problem. And some modeling work that I did a few years ago, quite a few years ago now, showed that as soon as you solve the food loss problem in the global south with the the post-harvest grain losses and things like that, basically what that means is the country's gotten wealthy enough to invest in decent quality grain drying facilities or grain storage bins and things like that, so that the rodents don't get into them and eat them and stuff like that. But as soon as you're that wealthy, you're actually wealthy enough that consumers start wasting food because food's not a big enough part of their of your budget. So it's kind of like a bit of a whack-a-mole. You push the food waste problem, or loss problem down, and the food waste problem pops up, and on it goes. So addressing the issue of food waste from a global north and a global south perspective requires entirely different approaches. One focused on farm, one focused on consumer. But my observation is that when you solve the farm-related ones, you end up creating, or you're in a context that's wealthy enough to create the food, the consumer-related ones. Oh, sorry, maybe I've misunderstood your question. Sorry, Stuart. I'm not asking about food. What are you asking about? I thought you were asking about food waste. Sorry. Do people maybe just repeat? Oh, sorry, nutritional quality. Your question has to do with nutritional quality. Let me just scroll back. Oh, sorry, I misinterpreted this. Yeah, I was half listening to Roy and half reading your question, and I got distracted. Apologies. Well, do people in the global north really value improved nutritional value and security, or is it in cereal, or is it simply a matter of taste and price? The evidence of consumer demand in the global north makes for kind of depressing reading. There's a small percentage of people that appear in consumer-related studies that do truly care about the quality and the provenance of their food. The vast majority of us are motivated by taste, convenience, and price. And if you want to drive change from a consumer perspective, you have to meet consumers in terms of taste, convenience, and price. And although there is a spoken, deliberate aspiration to buy more sustainable or more healthy, when you compare aspirations and surveys with grocery ticker tapes and actual surveys of what's being sold, or you compare what we aspire to do with what Loblaws knows it's actually selling, we as individual consumers don't come across very laudably. And where I've come to in this, and I used to spend a lot of time thinking about, well, if we could just communicate the virtuous components of this product better, then consumers will buy it. That notion of a green premium is a bit of an illusion, and almost all empirical evidence, other than that sort of 10% of really motivated consumers, the vast majority of consumers, it's taste, convenience, price. And what order those three things come in depends on income and time of the week and what the nature of the grocery store is, but it's always those three things. And anything else is a very, very distant fourth. Sorry, I hope I got to your question. I hope I finally answered your question there, Stuart. Apologies for that.
Richard Denton asks, he agrees with your diet recommendations, but the growing of technological food may not be delivering complete nutrients.
It's possible. I mean, certainly our current diets don't deliver complete nutrients either, right? I mean, like we're as a population, we know our current food system does not deliver appropriate nutrition. So at the level of the individual, if you are a highly health conscious individual and you're making good food choices now, will a vertical farm or a cellular hamburger change your quality of nutrition at all? Possibly there is a marginal risk that by eating a Beyond Burger, you're eating slightly less digestible protein and slightly more sodium than if you ate a beef burger. But that really depends on what you're comparing. Are you eating, if you compare a Beyond Burger with a Burger King beef Whopper, then you're probably no worse or better off. If you're eating a Beyond Burger versus a premium steak, then yeah, you probably should eat a premium steak. But at a population level, we know that the big problems are corn syrup and salt and fat in our diets. And so whether your salad greens comes from a field in California that's irrigated with broadcast irrigation and has a lot of pesticides dumped on it, or whether your salad comes from a vertical farm in Guelph that is not in the soil and doesn't benefit from the soil microbiome, but has a lot less pesticides and a lot less water embodied in it, it feels like a rounding error to me at a population level. Now, from an individual level, if it's a highly discriminating consumer who's already eating really well, then that's a different conversation. But at a population level, if you walk into Burger King and you buy a Whopper, and that salad that's in the lettuce that's in the Whopper comes from California's industrial system or a vertical farm outside of Guelph, feels like a bit of a wash to me.
Okay, I think we're running out of steam here. Let me just pose one more question and then we'll close up shop. I've been personally taken quite aback by what's happening in the artificial intelligence world.
As have we all. Whoa!
Well, particularly with the release of the letter by 1,000 researchers and CEOs last week, asking for a moratorium and further research and development of AI. And I think of this because of your own pitch for much better and stronger regulations in food production, and particularly so as we start to go down these technological roads of discovery. Do you have any apprehensions or thoughts about the need for greater regulation so that we don't end up with some unintended consequences like we did with the first green revolution? And if so, what would those regulations look like and how would they be delivered?
Well, in addition to the sustainability crisis, which you could put climate change and water and biodiversity all under that one horrible heading, I think the other big crisis facing society right now is the inequality crisis. And I am aware that these technologies that we're talking about today are being developed and coming onto the market faster than, if the talk that I gave today has to change radically every 2 years, because every 2 years I'm like, wow, that just happened in terms of technological development. I mean, my 2020 book that was written in 2018 did not, we were explicit. We did not think alternative proteins were going to be a thing. And then my 2022 book, which was written just 24 months later, was like, oh my God, I'm eating alternative proteins. That's how fast the technological curves are happening. And I am desperately worried that this technological moment of disruption will not deliver the hoped for benefits in terms of a reduced carbon footprint and reduced water impact and freed up land for agriculture. That it will just simply result in another generation of food tech billionaires. And that would be not only a terrible outcome, in my opinion, but also a huge missed opportunity. So, for instance, one of the so-called hoped for benefits of, say, a vertical farm is that it frees up land from agriculture. If you can produce, 1,000 times more lettuce in a box in a suburb outside of Guelph than you can in a field, then maybe that land should be put back to that you're not using anymore, could be put back to a higher and better purpose for protecting biodiversity. But that statement there is an entirely theoretical academic exercise that you could farm intensively in a box and spare land for biodiversity. That will only happen if there's some sort of compensation to the farmer who currently has that land that you no longer need and allows them the luxury of promoting environmental goods and services on that land. So there's a huge need for policy and regulation that stretches across jurisdictional boundaries to ensure that sustainability transition actually happens. So for instance, if we imagine a scenario in the not too distant future where a large amount of, say, Ontario's lettuce is produced in Ontario, just like a huge amount of our cucumbers, peppers, and tomatoes now come from our greenhouse industry. Well, that means that there's a lot less imports coming in from California. And what does the farmer in California do? Do they pave over their farm and build an Amazon fulfillment center? Or do they invest in regenerative agricultural practices or rewild their farms and whatnot? And those positive environmental outcomes will only come if there's policy and economic incentive to do that. And so really, what I'm spending a lot of my professional life on is figuring out what the supporting regulatory structures need to be in order to ensure that these technologies don't just create another generation of tech billionaires, but also produce the environmental benefits that we think they have the potential to. But we can't take that for granted.
Okay, let's leave it there. And I think you've given us a number of not only things to think about, but also challenges as we go forward over the next 2 years in this new world, which we hadn't imagined just a couple of years ago. Evan, thank you so much for your thoughts, for your stimulation, for being with us for.
My pleasure, and I'm going to say hi to Elizabeth, who's on the line. And Elizabeth, I just looked at the participant list. Nice to think you're on the line, Elizabeth. And immediately I'm suddenly seeing your name, and I'm thinking, shoot, I didn't talk about the labor implications of all of this, which are significant. You should have asked me a question about labor, Elizabeth. But anyhow, we're going to call it a day there. Thank you, there, Roy.
Okay, well, thanks to Elizabeth and the rest of the participants, and most of whom had an opportunity to launch a question or two. And I'm sure we will be checking back on this issue if not on a regular basis, on a basis that is needed to keep up with what's going on. So thanks all. Take care.
Bye for now.